Hello everybody, this is Dr. Christopher White, and in this video we're going to be looking at exercise 14 from Interpreting Earth History by Ritter and Peterson. Okay, so we're going to turn to page 217. So in exercise 14 we're going to be looking at the Canadian Shield and the stable platform. So if you remember, the Canadian Shield and the platform are areas of Precambrian crust. In the case of the shield, it's an area of the Precambrian crust which is exposed, so you can walk on it, you can physically touch it. And in the case of the platform, it's an area of Precambrian crust which is covered by younger deposits, so you cannot access it. So what do we have? Well, in the purple box here, of course, we have the learning objectives, and then of course we have a very brief rundown of the Canadian Shield and the stable and the platform, and that rundown continues just onto page 218. There's even a diagram here which shows you areas of exposed Precambrian rocks here in this kind of brown colour. So you can see here is the Canadian Shield. We have the stable platform in this kind of golden colour, and you can see that's the platform for North America there. And then we have the modern belts you can see in other areas. So you can see that a lot of the Earth is actually either exposed Precambrian rocks or essentially younger deposits on top of Precambrian rocks. And we can also see that these Precambrian rocks form the cores of pretty much every continent out there. Alright, anyway, so let's get on to the lab. Alright, so on page 218 we are going to find part A. So what we're going to do is we're going to carefully examine figure 14.2. So figure 14.2 can be found on page 220. Okay. I'm actually just going to take a second. I'm going to see if I can focus the camera just a little bit better to try and make a slightly sharper image. I'm probably not going to be able to do it. We shall see. Honestly, I'm just making it worse, aren't I? Yeah, that may be a small improvement. So let's go with that. So what can we see here? Well, now, if you've watched the lecture, and hopefully you have, you will see that these are the provinces that make up the Superior Province, or should I say the North American Superior Craton. So we can see we have the Superior Province here, we have the Hearn Province, the Ray Province, Slave Province, Wyoming Province, Sask Province, and then we have the Yavapai Province down here, Matzo-Labradorian Province here, Granite Rhyolite Province down here, Grenville Province over here. These are terms that, of course, you're all familiar with now if you watched the lecture. And you know that all of these provinces combined together help to essentially make up the geology of the Precambrian continent of Laurentia. Laurentia, of course, became North America, when we transitioned from the Paleozoic into the Mesozoic. So, okay. So all of these provinces combined form the core of North America. Now the other thing you'll see on this diagram here is you can see we have this grey band coming through here. Now this is the Trans-Hudson Orogeny. So if you remember, once again, going back to the lecture, you will know that the Trans-Hudson Orogeny essentially represents the location of a very, very large mountain belt that was produced by the collision of the Superior Province with the Hearn Province and the Wyoming Province with the Hearn Province and the Superior Province. And essentially it ended up in this mountain range here that essentially bifurcates here and comes this way and this way. So essentially it's kind of almost a Y-shaped mountain range. So, okay. We're familiar with all of these parts of the of the North American Craton, should I say. You can also see down here in the bottom left we have essentially a chronology, so we can put these pieces of crust in order, and we also have dates for them here as well. Alright. So part 1 is quite straightforward. It says list the Archaean provinces and cratons of North America. Well, how are we going to do that? Well, we're going to go back to our diagram. Okay, here we go. And if we look down here, here we go. These are the Archaean rocks. So you have this kind of pink and brown, kind of like brown and grey and purple. And so what you're going to do is you're going to look for the rocks on this diagram that match these colorations. So here we have pink and brown, here we have brown and brown, and here we have grey and purple. And so you're going to find all the provinces that have these colorations here, because they're all Archaean, and you're going to list them here. And that's it. That's all that question is asking for. Okay? Next thing we're going to look at is question 2. And question 2 asks you to estimate the percentage of modern North America that is formed by the end of the Archaean eon. Okay, so once again, Archaean. Now that means we have to discount all of these Proterozoic rocks. So all of this material here essentially does not exist. You'd be focused on how much of North America does this material here make up. Okay, so you're going to have to come up with a number, and you're going to give me a number in the form of percentage here. So next, question 3. What is the Abitibi Belt, and what age/type of rocks are exposed there? Okay, so the Abitibi Belt. Let's try and locate that. So let's have a look around. It'll be around here somewhere. Aha! There it is right there. Oh, sorry, let me just get the diagram. There we go. So the Abitibi Belt is located right here. Now obviously you can get the age of the rocks of the Abitibi Belt, because obviously you can read off the age of these rocks on the key down here. So you can do that bit pretty easily. So the next question is well, what is the Abitibi Belt? And what are the types of rocks? Well, this is one of these moments where I'm afraid, number one, you can have a look at the lecture material, because the Abitibi Belt does pop up in the lecture material. Or you can spend a second and you can jump onto Google and Wikipedia, and they will help to guide you with what the Abitibi Belt is, what rocks are there, what the age of those rocks are, and essentially just explain generally what's going on. So once again, this is a relatively simple question. Just stick to what you are being asked. So what is the Abitibi Belt? What age is the Abitibi Belt? And what rocks make up the Abitibi Belt? Done. Question 4. Discuss the nature and significance of greenstone belts. Now that's going to tie back into question 3 here. What type of rocks characterize greenstone belts, and why are they restricted to Archaean provinces? Okay, well once again, this is going to go back to some, number one, the lecture, and you are also going to have to spend just a second just jumping onto probably Wikipedia would be a reasonable place to go and have a look. If not Wikipedia, then Google in general. Okay, and so once again, stick to what it asks. All right, what type of rocks characterize greenstone belts? Why are they restricted to Archaean provinces? That's what you're aiming for. Okay, so when it comes to the rocks, well obviously you can sort that one out pretty easily. Why are they restricted to Archaean provinces? Well, it's a question of when were greenstone belts forming? What process produced greenstone belts? Okay, so if you remember when we spoke about greenstone belts in the lecture, we started talking about things like the collision of island arcs. Alright, so when we're talking about the collision of island arcs, well yes, in the modern environment and during the last 541 million years, yeah, there have been plenty of collisions with island arcs, but when it really comes down to the rate at which these collisions occurred, when do you think in Earth history the rate of those kinds of collisions would have been at its highest? Also, you can discuss, maybe think about things like ophiolites as well. Now, ophiolites is another possible mechanism for the formation of greenstone belts. I don't like it personally too much, but it's another model out there. There's lots of reasons why these greenstone belts are more common in Archaean aged rocks. Okay, so I would personally say focus more on the kind of collision of island arc kind of, idea, and think about why, what time in Earth history were these island arc collisions, at their maximum, because that's obviously when you're going to get most greenstone belts formed. Question 5. What is the nature, so geographic distribution, rock type and age, and significance of the trans-Hudson orogeny in the evolution of ancestral North America? Okay, so what's the geographic distribution? Look at the diagram and tell me. What's the rock type? Okay, in this case, you're going to have to go online, but also, once you know what the trans-Hudson orogeny is, and I mentioned it to you a little bit earlier in this video, you can kind of guess relatively easily what the rock types, in that area will probably be. The age, well, that one's really easy. Look at the key. And think about what it means in the evolution of North America. Well, we've just gone and discussed that the trans-Hudson orogeny was produced by and you can fill in the blanks from what we discussed at the start of the video. And of course, this event is going to help to stick pieces of crust together, isn't it? And that's going to help to build the core of North America. So, it's a pretty important event. Question 6. How do the ages of the rocks in the coloured map area of figure 14.2 support the concept of continental growth by accretion? So if you remember, accretion is the process of continental growth simply by stuff sticking onto the sides of your continent. So if we are using an accretion based model, where would we expect to find new material located essentially on our continent? Now, if we have a look at the map here, okay, now remember, we can look at the column here and we can see what the new material should look like in terms of color, shouldn't we? Okay, so where is that new material located? Is it located in the middle, at the margins? Is it just everywhere? Is it, homogeneously distributed? What does that tell us about its distribution, and what does that, how can we relate that back to accretion? Okay, and then we're going to cite specific examples of patterns that support this concept. Once again, when you go back to the map, look at where this material is distributed, and then obviously once you can see where it's distributed, then you can use that as your evidence for accretion. Okay, question 7. What is the age, nature, so rock types, fault styles, and significance of the mid-continent rift? So this mid-continent rift was discussed as part of the lecture. Alright, so it is mentioned. But if you want to know the age, well, that one's really easy. So the mid-continent rift is right here. Oh, look, there's a key of some ages right there, so that one's easily done. What are the nature of the rocks in this what are the nature of the rocks in this mid-continent rift? Well, once again, in that instance, think of modern mid-continent rifts. East African Rift Valley is a good example of one. Think of the types of rocks that are being formed there. Fault style. Well, this is an area that's under tensional forces, so the area is under extension. So think about the type of fault that form in extensional regimes. And then think about the significance of the mid-continent rift. So we discussed the significance of it. The mid-continent rift is a failed rift. It didn't succeed. North America tried to pull itself apart. So in that respect, it's not actually that important. But the significance of it is, imagine what would have happened if it had succeeded in rifting and splitting North America in two? What would happen then? So that would have had very serious repercussions for the development of North America, wouldn't it? So have a think about that. Okay. Question 8. Where was accretion, a tectonic activity, prevalent in Laurentia during the Paleo and Mesozoic eras? Okay. So where was accretion and tectonic activity most prevalent during the Paleo and Mesozoic? Proterozoic, sorry. Okay, Proterozoic, Paleo, Proterozoic, Mesoproterozoic. Where is most of the activity taking place? Look on the diagram. Tell me that. Is it all over the place? Is it along the edges? Is it in the center? Is it in one band? Tell me. What provinces were added to ancestral North America during these two eras? So by ancestral North America, it's talking about the Archaean rocks. Approximately how much larger, percentage-wise, was Laurentia after these provinces were accreted compared to the size of the continent at the end of the Archaean? Now, there's a couple of ways you can give me this number. The first way is you can say, right, how much mass was added to the Archaean? So you can say, right, well, the Archaean was this size, and then after the addition of this mass, the Archaean was 50% larger. Okay, that's the first way of doing it. The other way of doing it is saying, right, well, the Archaean made up 50% of North America. After the Meso and Paleo-Proterozoic, the core of North America, so essentially the Precambrian rocks, made up 75% of North America. So you can, simply say, oh, the Archaean, it was this big in the Archaean. Then once you added the Proterozoic stuff onto it, it became this big. Or you can say, you can relate it to the size of North America. So you can do it either of those two ways. Just please try and make it clear which way you're doing it, just so I know. And then finally, question 9. The Paleoproterozoic, now this is going to be terrible, Antimiki group outcrops in the area south and west of Lake Superior. So we would find it essentially in this area here. Okay. It is chiefly composed of sedimentary and metasedimentary rocks deposited in the Antimiki Basin between 2.5 and 1.8 billion years ago. These rocks are economically important because they contain vast amounts of iron in the form of banded iron formations. We spoke about them in the lecture. Briefly explain the nature and origin of banded iron formations in the context of Earth's evolving atmosphere. So, what do banded iron formations tell us about the Earth's atmosphere during this time period? Go and look at the lecture. Okay, if the lecture doesn't quite work for you, obviously you can read the textbook, you can go to Wikipedia, you can go to Google. There are many sources of information available to you. And then we have question 10, which we're not going to be doing. Okay, so that's part A. Lots of little questions, just trying to make you think about certain parts of the Archaean and Proterozoic continent of North America. Okay. So then we move on to part B. So next we're going to carefully study the geological relationships portrayed in figure 14.3. So 14.3 is this diagram on page 221. So you can see here we have our shield. So these are exposed Precambrian rocks. And here in brown, we have our platform. So this is where Precambrian rocks are covered by younger sediments. Okay. Question 1. So note the thickness of the sedimentary strata covering the stable platform as indicated by the contour lines. How thick is the sedimentary rock cover throughout most of the platform? Where is the cover thickest? Okay, so as I just mentioned, the cover is this brown material here. Okay, so the first question is, you can see we have all of these brown lines right here. You can see there's one here. You can see there's some here, here, here. They're all over the place. So the first question is what's the most common number associated with these brown lines? You know, is it 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, etc.? What's the most common depth of sediment? Next, where in this diagram is the sediment at its thickest? So obviously you're going to look for the contour lines with the highest numbers. Okay? And the other thing it wants from you, so it wants to know what's the normal thickness and where is it at its thickness. Where is it at its thickest? So it just so happens that we have the contour lines, and associated with these contour lines there are numbers. And these numbers relate to the list of sedimentary basins right here. Okay, so look at these contour lines, look at where the sedimentary cover is at its thickest, find the correct basin, and write it here. It's okay if there's more than one answer. If there is more than one answer, give all of them. Okay, so question 2. So the stable platform of North America contains a number of basins that have resulted from increased subsidence and sedimentary infill. Obviously, sedimentary infilling, should I say. Some of the major basins are numbered 1 to 11 on the map. We just saw that a second ago. So using the textbook and other reference materials such as Wikipedia or other websites, fill in the requested information for each of the intertectonic basins in table 14.1 right here. So for each of these basins, you're going to write the location, the age of the rocks, and the resources that we find in that basin. So, you know, most of the basins like the Michigan Basin, the Illinois Basin, the Appalachian Basin, you can find that information on Wikipedia really easily. So most of this table you can do very, very quickly by using both the textbook and Wikipedia and Google. Now, some of the other basins, like the Powder River Basin, that one's not such a major basin. So the information on sources like Wikipedia will be a little bit more sparse. So in this case, you may have to go to Google to find specialist websites that discuss the Powder River Basin. Okay. So obviously you're going to tell me the location first of all. Well, that one's quite straightforward because if you look at the map here, it gives you the locations anyway. But once again, it would be wise to go onto Wikipedia and other sources and actually get the location. And what you're going to do is you're going to tell me things like what state or states the basin is located in. Okay, so don't just say, oh, it's in the southeast United States. Well, the southeast United States is pretty big. So what you need to do is you need to tell me what's the location. Okay, which American states is it in, or if the basin happens to be in Canada, what Canadian provinces is the basin located in. Okay, so that's location. Age of the rocks. Well, the age of the rocks is quite straightforward. When you go on Wikipedia, it's going to say, right, the Michigan Basin is, a mixture of sedimentary rocks dating from between the Silurian and the Carboniferous. So you would write Silurian to Carboniferous in there. Done. In terms of the resources, well, once again, if you're on something like Wikipedia, it's going to say the Michigan Basin, has numerous resources, including, and it will say things like maybe oil, natural gas, coal, limestone, salt, things like that. And you would write those in the resources area right here. So this isn't a particularly difficult exercise, but it is going to take a little bit of your time. And the reason you're doing this is to let you know just how important these Precambrian rocks are or Precambrian rocks and the basins that sit on top of them are when it comes to the resources of North America. So the shield and the platform are extremely important economic areas for the United States and North America as a whole. Okay, so on to question 3. So sorry, just let me adjust the page slightly. Here we go. The Adirondack Mountains of New England are comprised of Precambrian rocks. What is the age and nature of these Precambrian rocks? To which Precambrian province do they belong? Okay, so let's try and find them on the diagram. Here they are, right there. Okay, you can see there's an arrow pointing to them. So, first, what is the age? Okay, well, you can see there. Go to your key. Stage 1, done. What's the nature of these rocks? Well, that's going to be a little bit more difficult, but once again, jump on Wikipedia, jump on Google, type in Adirondack Mountains and find some information. Find some information about the types of rocks that occur there. And to which Precambrian province do they belong? So what you're going to do is you're going to look at the position. Okay, so note it's just north of that point in the coastline right there. So just note that. And if I'm trying to guesstimate how far in it is, I'm going to say it's about, it comes to about there on my pencil. So I'm going to come over to this page here. I'm going to look for, oh look, there it is again there. Then I'm going to put my pencil on my page and I'm going to go, this is the province that it falls onto, or falls into, should I say. So you can do that for yourself. I'm not going to do that for you because it's relatively straightforward. Question 4. So the Bighorn Mountains of Montana and the Black Hills of South Dakota are both covered by Precambrian crystalline rocks that have been exposed by uplift and erosion. So to start with, let's find the Black Hills and the Bighorn Mountains. Okay, here we go. There's the Black Hills, and here are the Bighorn Mountains. So these are the two locations. So they're actually pretty close to each other, not very far apart. So if you studied rocks in the two areas during an extended field trip, would you find them to be similar in lithology and in age, or would you have examined rocks from two distinct Precambrian provinces? Be specific in your answer. You may wish to refer to figure 14.2. Okay. Well, the first thing you need to do is you need to work out where these two locations fall on this map here. Because to start with, that's going to tell you what provinces they fall into. And obviously, once you know what provinces they fall, or maybe they're in the Superior Province, maybe they fall in the Trans-Hudson Orogeny, maybe they're part of the Matzo-Labradorian Province, for instance. Okay. And that's that would mean they would have different ages, they may have different rocks, and it means they would have different tectonic histories. So all of this would have to be included in that answer for part 4. So how are we going to work out where they should fall on this diagram? Well, it's quite simple. If you have the hard copy, then all you do is you take a ruler and you measure right. So we're going to look at the Black Mountains. The Black Mountains are 7.7 centimeters in from the edge, and they are 10 centimeters up from the bottom. So use those 2 points and work out where, use those 2 measurements, should I say, and work out where the point falls on this diagram here. Do it for both locations. Alright. Now, of course, if you are using the digital version of the textbook, what are you going to do? Well, once again, it's time for a good old-fashioned screen grab. So take a screen grab of this page, take a screen grab of this page, dump them into a program. I personally prefer PowerPoint just because I find it a little bit easier to work with than Word. It's a little bit less clunky. Dump the two images into PowerPoint. Make sure they're the same size. Do not scale them to different dimensions. And then obviously what will you do? Well, you'll just put a square in. So start your square down here and expand your square until the corner of it hits the Black Hills. So you'd have a square that would cover this entire area here. It would come down like that. So this entire area would be your square. Then take that square, cut it, and paste it onto this diagram. Position the square with the bottom corner down here, and there, whenever the top right hand corner of the square falls on this diagram, will obviously be the location. So it's also relatively easy. Now once you have the location, that's obviously then going to help you answer questions like, where are we? Would we expect to find similar lithologies? What would be the ages? What would be the geologic history of the rocks? So you'd be able to answer that question as soon as you begin to work out which province these two areas are located in. If the Bighorn Mountains and the Black Hills of South Dakota are located in the same province, well, chances are they've had the same geologic history, they're made of the same rocks, etc., etc., etc. If they fall in different provinces, well, then obviously they're going to have a different geologic history, different rocks, etc., 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 different ages. So that would go onto your page here. Finally, we have figure 14.4, which is this picture right here. So it shows the inner portion of the, it shows a portion of the inner gorge of the Grand Canyon. So here we have Precambrian rocks at the bottom, and they're overlain by Cambrian rocks here. And you can see the contact coming through there, like so. All right. So the Precambrian rocks are overlain unconformably by the Cambrian Tapete sandstone. So this is the Tapete sandstone here, and this contact I just pointed out to you is going to be an unconformity. The crystalline rocks beneath the unconformity form part of which Precambrian province illustrated in figure 14.2? Okay, well, we know it's the Grand Canyon. So once again, here we go. Inner gorge of Grand Canyon. So what we're going to do is we're going to work out how far in, how far up, and then we're going to transfer those measurements onto this diagram here, and we're going to work out to which province the Grand Canyon belongs, or more accurately, to which province the Precambrian rocks of the Grand Canyon belong. And then obviously you're going to put that answer here to answer part 5. And then that is it. So exercise 14 is not a particularly long exercise, but it is going to require a little bit of effort, but that effort shouldn't be too mentally taxing. It's pretty light work, but there's quite a lot of it. Alright guys, so exercise 14, yes, I know it's a bit more work than some of the other exercises, but this is all about trying to make you think about the Precambrian rocks of North America. Okay, and it's also trying to make you think about the Precambrian rocks of North America and thinking about just how valuable they are to North America and how they shouldn't just be ignored, because when it really comes down to it, Paleozoic rocks and Mesozoic rocks and Cenozoic rocks tend to be considered more interesting because they're full of fun stuff like fossils. However, Precambrian rocks are very, very important, and in my opinion they're actually even more fun than the younger rocks because they have more information in them and they've suffered a far more interesting history because they've been around for longer. Alright everyone, so that's it for exercise 14. So give it a whirl. Obviously if you have problems you can ask me about it during office hours at the allotted time and date, or allotted time and day should I say. Alright, have a good day everyone, bye.